Okay. First of all, as you see, there's a change in topic. I am not going to talk about clauses. If you want to know what I have to say about clauses, if you want to know what I have to say about clauses, you can find it in here and in here, the cognitive grammar book and the categorization book. I want to talk about another topic. I've chosen for the final talk a topic in phonology. And actually I'll cover a number of various topics in the course of the lecture. Obviously phonology first of all. I will also have something to say about acquisition, specifically first language acquisition by infants, by children. I'll also have to say something about the history of linguistics, American linguistics in particular, in the 20th century. And I'll also I'll make reference to the literature in psychology and cognitive science and computer science. So a lot of topics. The strange title has to do with the fact that phonemes, well, we all know what phonemes are, I presume. You all know what phonemes are, the sound units, of which there are about 45 in English or whatever. Phonemes are used in linguistic analysis. And first of all, the phoneme concept in linguistics is somewhat controversial. Some people say you don't need them. For others, the phoneme is a basic phonological concept. That's one reason why phonemes are interesting. Another topic I want to address is, do speakers of a language actually have phonemes? Do they need them? And if they do, where do they come from? What is the basis of phonemes? Okay. So, let's begin at the beginning. And for me, the beginning of linguistics, well, actually that goes back to when I was an undergraduate student in Cambridge and did linguistics. At that time, there wasn't really a linguistics department. There was one professor who was on sabbatical, so there was basically no one. And I went to see him, and he said, well, here are two books, go away and read them. And the two books were Bloomfield's Language, published 1930, so Leonard Bloomfield's book, Language, and the other was Saussure, his course in linguistics. And he said, you can read it in French or English, but it doesn't matter. That was published about 1918. And those two figures, Saussure and Bloomfield, in fact, very greatly, I think even now, influence the way I think about language. Saussure is often regarded as the father of modern linguistics in the West. He established what is well known for the arbitrary nature of the sign, that is the relation between sound and meaning. One aspect of Saussure's thought I find very attractive is that Saussure insisted that the sign related, the sign, linguistic sign, did not relate a thing and a sound to the concept and an acoustic image. In other words, it was a mental entity relating the concept of a thing and, in fact, the concept of a sound. Right? Bloomfield, as you will know, established American structuralist linguistics in the 30s, and his influence, he basically dominated, especially North American linguistics, basically until the arrival of Chomsky, who then overturned everything, as we'll see. And the rest is history, as they say. Okay, so I want to draw on these two writers, but beginning with Saussure. I want to begin with a quotation from Saussure. Read the bottom part. That's the English translation. This is a very famous passage in Saussure's course in general linguistics, in which he points out that thought, right, cognitive activity, is has no shape, has no form, except through the linguistic system. So psychologically, setting aside or leaving aside, forgetting its expression in words, our thought is simply a vague, shapeless mess. So without language, you wouldn't be able to think, basically. You just have a vague, whatever. You wouldn't have thoughts, you wouldn't be able to reason, you wouldn't have concepts. Were it not for signs, that is linguistic expressions, words and so on, we should be incapable of differentiating any two ideas in a clear and constant way. In itself, thought is like a swirling cloud where no shape is intrinsically determinate. No ideas are established in advance, and nothing is distinct before the introduction of linguistic structure. One can disagree with certain aspects of that. Probably, I wouldn't want to say that certain ideas, certain concepts are innate, after you are born with them, but certainly we are born with predispositions to have certain concepts. Anyway, this is a rather extreme position, which of course leads to a position of extreme linguistic relativism, that your thoughts, your thinking is determined by your language. Without language, you wouldn't be able to think. Now, interestingly, Saussure goes on to say that the same is actually true of sound, right? The acoustic, phonological aspect of language. The substance of sound, that is the actual sound that you make, speaking, the substance of sound is no more fixed or rigid than that of thought. So the kind of sounds that we use in a language does not offer a ready-made mold with shapes that thought must inevitably conform to. It is a malleable material which can be fashioned into separate parts in order to supply the signals which thought is in need of. In other words, to simplify that, it means that the sounds that you hear in a language, in your language, the vowels and consonants and syllables that you hear in your language, they are actually not there. It is the language that you know which enables you to hear words, phonemes, sounds, consonants, vowels, and so on. One cannot actually prove that this is right or wrong. We cannot put ourselves in the position of a person without language. We cannot imagine what it would be like not to have a language. We can't put ourselves into the mind of a newborn infant without language. That is clear. We don't know what it's like. We can't put ourselves into the mind of an animal which doesn't have language. But when it comes to sound, we do have the experience, actually, of listening, of hearing languages which we don't know. And if you listen to a language which is completely unknown to you, I mean, not at all related to your own language, a language which you haven't been exposed to at all, so you hear a completely unknown language, what do you hear? Well, you hear simply a mass of sound. It's difficult even to identify, you can't identify words, obviously. It's difficult even to identify what the vowels and consonants are. It's simply, a blur of sound, if it's spoken quickly. So to some extent, you can have the experience of what it is like to listen to a language without having that language. Okay, now I mentioned the case of newborn infants. Children before they have language. Now, actually quite a lot of research has been done on the abilities, on the cognition of newborn infants. Up 2, 3, 4-week-old infants. And it's quite sophisticated research because obviously you can't ask them questions. You've got to design experiments and see how they respond. And quite a lot of research has been done on the phonetic, acoustic abilities of infants. Now, what do infants hear when they hear a language around them? Well, you might think, well, they also sort of hear a blur of sound, nothing is different, nothing is distinct, and learning the mother tongue means learning to distinguish all the sounds that they hear. First of all, I mean, it's just a blur, indistinct, and then they must learn that this is different from that, and this must be distinguished from that, and so on. But remarkably, this is not the case. A lot of research has shown that newborn infants can actually hear all sorts of things. They can hear things that we can't hear. And newborn infants are extremely sensitive to speech sounds, and they are able to discriminate, that is to tell the difference between all manner of contrasts which are used in just about all the languages of the world. For example, when you begin to learn English, you might find it difficult to hear the difference between a s and a th. Children can do it. When I learn a language other than English, I find many of the things difficult to hear. Children can do it. Okay. You may be wondering, how do we know that newborn infants can do that? Well, one experimental technique involves infants sucking. They suck on the dummy. They are lying, sucking. And basically, what happens, the infant is lying there sucking on the dummy, or pacifier, as Americans say, and there's a loudspeaker going ba, 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 ba. And when the loudspeaker starts going ba, ba, the child gets interested, stimulated, excited, something is happening, so it starts sucking faster. But after a time, the thing goes ba, 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 and the child gets bored, and so starts sucking on the dummy at the regular rate. Now, what happens is that you change the sound that is presented, so that ba, 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 da, 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 you change from one sound to another. And the idea is, does the child notice? And if the child notices, there's a change, so the child starts sucking faster until it gets bored again and goes back. So that experimental setup, as you can see, is a way of actually investigating whether the child can hear the difference between two things. Right? And those experiments, as you see from the dates here, they were done actually quite early. The first one was actually in 1971, so a long time ago. And it's been done repeatedly with children from various language backgrounds. So children born into an English-speaking environment can hear the sounds that are needed for Spanish, for Chinese, for Japanese. Conversely, those born into a Japanese family can hear the sounds that are important for English. So it seems that infants can actually hear everything. And acquiring the sound system of your language, in fact, is not learning to make difference, but rather it's forgetting. Initially you can hear everything, but then you must learn to forget. You must learn not to hear, in fact. So newborn infants are extremely sensitive to speech sounds, and they can hear everything. Well, hear all different. Now, this ability, the word discrimination is a kind of technical term for which psychologists use. To discriminate is to see that two things are different. So discrimination ability, the ability to hear that this is different from that. Right? Now, discrimination ability alone is clearly not sufficient as a basis for acquiring the phonology of your language. In order to acquire the phonology of a language, you have to categorize. It's not enough if you can hear 10,000 different sounds. Basically, to hear English as English, you've got to hear basically 45 sounds. You've got to categorize. So it's necessary for categories of acoustic events to be recognized in the kaleidoscope, in the ever-changing auditory impression. In other words, some chunks, some bits of sound that you hear have got to be regarded as being the same as other bits. If everything is different from everything else, you cannot categorize. you cannot reason, you cannot draw conclusions. So if every experience that you have is completely different from, or is perceived as completely different from every other experience, then you couldn't function. Right? You couldn't function. So some chunks, some bits of sound, have got to be regarded as being the same as other chunks. Just as if you're learning a right system, a particular letter of the alphabet or a particular character can be written in all sorts of different ways, according to your handwriting style, according to the font you are using, and so on. But in order to read, you have to ignore those differences. You have to recognize that these two shapes are the same for linguistic purposes. Now, the question then arises, what are these sound chunks, these bits of sound that the learner needs to identify and needs to categorize? Well, there are three possible candidates. There are possibly more, but three obvious candidates. What are you listening for when you listen to your language? What do you hear? Right? What are you listening for? What do you have to identify in sound? Well, three possibilities. You identify words. You are listening for words. You identify bits of words, such as syllables. Or you identify bits of syllables, that is, onsets and rhymes, sounds, as I might call them, or positionally conditioned allophones. I'm not using the word phoneme yet. By a conditionally positioned allophone, I mean, well, basic phoneme theory that, a p sound is different according to whether it's in the word put or tip. Right? The sound is actually different according to the context. Syllable initial versus syllable final. Okay. So the allophone, the sound that occurs in a certain position within a word or a syllable. Okay. So there are these various candidates. Now, okay, that might be okay. Okay. Now, the idea that when you're listening to speech, you're listening for words, in fact, there's quite a lot of evidence that this is true. First of all, it seems to make common sense. As when you listen to speech, when you listen to me, or listening to your own language, what you are listening for is words. Right? You are listening for the words. Right? So listening to speech is essentially a matter of listening for words. Words and things like words. I say word-like units because, as you may know, the question, what is a word, is actually not easy. But basically we know what we mean when you say listening for words. The kinds of things that are in dictionaries, basically. Listen. Okay. So listening for words and learning the language, and learning a language involves learning words and learning the sound shapes of words. What words sound like. Right? Now, a major researcher on the acquisition of phonology in children, Peter Juszczyk, suggests, in fact, that the identification of words in speech is basically what speech perception is all about, and he has lots of experiments suggesting that people do, in fact, listen for words, and that's what children listen for. At the age of 2, 3, when they are beginning to learn a language, what they're listening for is words. And a number of other phoneticians have proposed that basically it is the identification of word-like units that makes language acquisition possible, in fact, that gets language acquisition started. You don't listen for phonemes, you listen for words. Now, the final point is, during the earliest stages of language acquisition, at the age of 2 or whatever, when the child's lexicon is quite small, when the child only knows 20 or 30 words, right at the very beginning, when the child only knows, a dozen, 20 25 words. So when the child's vocabulary is quite small, it is possible, it is plausible that these words are learned, they are memorized, and they are used as wholes, as whole bits, as whole units, without any sort of analysis of them. Right? So they're learned as wholes without identifying consonants, vowels, syllables, just as whole things, without any internal analysis. Okay? It's a bit like when you learn a fixed expression and you simply learn it as a whole without realizing what words go into it. It's simply a whole thing. Okay, so it is possible, and a number of people have suggested that at the beginning, in the early stages of language acquisition, the first words are learned as wholes without any internal analysis. Okay? But there is a limit to the number of word wholes that you can actually store, retrieve, and recognize. As the number of words that you know increases, it becomes very difficult to actually remember them all. Right? It becomes very difficult to actually keep them apart. Okay? You've got to do some kind of internal analysis. You've got to break them down into the bits. So the number of different things that you can learn and keep separate probably is quite limited. You certainly couldn't remember 10,000 different whole units because you could never keep them apart. So you analyze them into bits. You break them down into bits. Now, what are the bits that you use? Well, probably, and here I'm speculating, it may well depend on the language. As you know, Japanese is a language with actually a very simple, syllable structure, and basically, okay, simplifying somewhat, there are basically 46 syllables in Japanese. Okay, it's not quite as simple as that. But with 46 syllables, you can remember 46 syllables without breaking them down into vowels and consonants. You can learn 46 different sounds. In the case of Chinese, and I think I'm right in saying this, there are basically 400 syllables in Chinese, not counting tone. If you add tone, it multiplies by 4 several times. But different syllables in terms of consonants, vowels, in terms of your onset and rhyme, or your initial and final, you have, I think, about 400. Is that right? Okay. I think you have 800 are theoretically possible, but only 400 actually exist. Now, at 400, well, 400 is quite a lot, actually. To learn 400 syllables, to learn 400 sounds would be difficult. In order to learn the 400, you basically got to analyze them into the first bit and the second bit. But when you turn to English, which has a very complex syllable structure, how many syllables are there in English? A couple of thousand, I imagine. Then you need further analysis. You've got to break these things down basically into sounds, consonants and vowels. As a logical necessity, right? Without having these sounds, you couldn't remember your 2,000 syllables or whatever. Okay, now, whatever the units are, whether they're words, syllables, vowels, consonants, or whatever they are, you have the same problem. And it's the basic problem of categorization, namely, all those things that you want to regard as the same are in fact, from a physical, objective point of view, right? We say, you learn the pronunciation of a word. Well, what is the pronunciation of a word? A word can be pronounced in many different ways. Speakers speak different accents, different voice qualities. You can speak it quickly, you can speak it slowly. You can speak it on a high pitch, on a low pitch. You can speak it with your mouth full of food or not. Right? So how a word is pronounced differs. according to speaker, and so on and so forth. And in fact, if you make a recording of a pronunciation of a word spoken twice by the same speaker and do your acoustic analysis, you will find that each pronunciation is different, right, in small respects. So the problem is variation. And that is exactly the same as we have when categorizing whatever it is. You have the category of a table. We know what tables are, but every table is different from every other table in exact size, shape, color, height, material. They're all different. But for the purpose of using language, you've got to regard them as the same. Right? That's what it means to categorize. Now, so the problem is variation. Now, to go back to my first talks on categorization, one approach to categorization is to say that a category is defined. A category is possible because every member of the category shares some essential features. These are the classical categories mentioned here. A classical category is defined in terms of a set of fixed invariant features. Now, when you turn to phonological categories like the sound of a word or the sound of a vowel, it's exactly the same with these as it is with, verbs and tables and whatever. Phonological categories turn out not to be classical categories, which you can define in terms of a set of invariant, stable, fixed, acoustic, or indeed articulatory features. Now, this actually was discovered, as you see from the dates, actually quite a long time ago, when acoustic analysis of speech got underway in the 50s and 60s. People thought, well, it should be very easy, actually, to build a machine where you put speech in one end and you have a written version out the other end. Right? So speech in and writing out. A kind of, a machine which takes dictation, so to speak. You say a word and the machine prints it. Now, 50 years after this, of course, we do have this is now possible. I mean, personal computers have this device for converting speech into writing, right? But that has been possible after decades of very, very intensive research. What the researchers thought in the 1960s and so on was it would be a simple matter. You have, say in English, the a, say the word cat, you have a k, a, t. You say what are the acoustic features of k, of a and t. You identify those acoustic features, so the input is cat, output k, a, t, and you write it out. Now, it didn't work. And it didn't work simply because of this question of variability. Let us say the a vowel in English has all sorts of pronunciations, and you cannot identify a on the basis of fixed invariant features. Okay, given this, it would be reasonable, one would think, to look at these phonological categories with the insights, applying the kinds of things we have learned with respect to other categories. What we have learned about categories like birds and furniture and chairs and whatever. What we have learned about those categories perhaps they can be applied, interestingly, to phonological categories. In other words, do phonological categories have a prototype structure, for example? Now, I want to change the topic a little bit and come back to phonemes. And here a little bit of linguistic history. When doing linguistics, it's always very useful, well, indeed when studying anything, I think, it's always very useful to have some awareness of the history of the subject you are studying. Right? In other words, it's important not just to read the latest stuff, but also quite interesting to look at what people were doing 100 years ago in your discipline, what they were doing 50 years ago, to have some idea of the historical development of your discipline. Now, linguistics, especially in North America, but to lesser extent in Europe, in the 30s and 40s, what was it about? Well, if you look at the journals of the time, the major linguistics journals of the 1930s and 40s, they're all about phonology. Well, not all, but quite a lot of them are about phonology. And what were they concerned with? They were concerned with how to identify the phonemes of a language. That was a major concern. And there was a certain orthodoxy, there was a certain way of doing this. And basically what you did was this. You went out amongst native speakers of a language. In North America it was especially, of course, the Native American Indians. But you went out amongst the native speakers of a language. Well, you didn't take your tape recorder because they didn't have tape recorders. You took your notebook and a pencil, and you wrote down phonetic transcriptions of what the natives said. Right? You transcribed what the natives said. Okay? A very fine, detailed phonetic transcription. And then you went home and looked at these phonetic transcriptions, and then you tried, on the basis of your phonetic transcriptions, to work out what the phonemes were. Okay? And having done what the phonemes were, you tried to work out what the words might have been, what the morphemes and words might have been. And having identified the words, you then looked at what the syntactic rules might have been. And in doing all of this, at no point were you allowed to ask the native speakers what they thought about it. You weren't allowed to mention the word meaning or intention or anything. It was a prohibition on the so-called mixing of levels. You started with the phonetic transcription and you identified the phonemes. You did not make any reference to what it meant. Right? No reference to meaning. And having done the phonemes, you then identified the morphemes, and so on. So you started at the bottom, right? Identifying the phonemes, then the morphemes, then the words, then the grammatical rules. But at no point could you look at the higher level. So you identified the phonemes without reference to words. You identified words without reference to syntax. You identified the syntax without, of course, any mention to meaning. It was a bottom-up thing. And a couple of quotations to support this. One from 1942, one of the major linguists of the time, Charles Hockett. No grammatical fact, that is syntactic fact, of any kind is used in doing phonological analysis. Another from Bernard Bloch. We shall avoid all semantic and psychological criteria. We won't ask people what the words mean. We'll simply make a transcription of them and then go home and analyze them. Okay. Now, when you read this stuff of, well, it's now, 70 years ago, isn't it? When you read this stuff of such a long time ago, it's as often happens when you read texts from an earlier period, you think, well, this is all very strange. It looks all very strange and weird and not really relevant to modern concerns. I mean, nowadays, if you're doing phonology, of course you make reference to syntax, to morphology. If you're doing syntax, of course you look at what it means. Right? You can't. Nowadays we would not do syntax without looking at meaning. You wouldn't simply look at how a word is distributed without considering what it means. I mean, that is what we do nowadays. It seems quite silly to look at the phonology, the sound of a language, without considering what the words are. Right? So it looks all very strange. And rather silly, perhaps. But what I want to suggest is that we can give a modern interpretation of what these people were doing in the 30s and 40s. And here I want to bring in two concepts which are taken not from linguistics, in fact they're taken from cognitive science and learning theory, so-called supervised learning and unsupervised learning. So these are terms from cognitive science, cognitive psychology. How do people learn and how do machines learn? Right? Learning in machines as well as people. Okay, so two principal kinds of learning, supervised and unsupervised. Supervised learning, well, I'll give you an example of the kind of supervised learning that psychologists would do. The psychologist makes up a category, and the category is, let us say, anything that is green or yellow and that is either a square or a circle. That's your category. And then then you are the subject, and then you're shown pictures of circles, squares, triangles, and different colors. And you're shown this picture, and you have to guess yes or no. Is it in the category or is it not in the category? Now, first of all, of course, you haven't a clue. You answer randomly, yes, no. And then you're told whether your answer is correct or not. And after you've done this about 50 or 100 or 200 times, you're shown this picture and you say yes, in the category, no, not in the category. And then you are told whether your answer is correct or incorrect. After you've done this a couple of 100 times, you begin to realize maybe, you stop guessing and try to work out exactly what it is you're supposed to be learning. And eventually, perhaps, you finally work out what it is you're supposed to be learning. And then you answer everything correctly. Okay? Now that is the kind of thing that psychologists do, or they used to do. I think they still do it, actually. And this is called supervised learning. And it's supervised because you have the experimenter who gives you information on whether you are responding correctly or incorrectly. So in supervised learning, the learner is presented with a set of stimuli which are labeled as either a member or a non-member of some category you are learning. And the learning and the labeling may take the form of feedback. You are told whether it's right or wrong, whatever. And after you've been doing this for, say, 50, 100, 200 times, the learner may be tested on new stimuli, which are then presented without labeling or feedback. And the aim is to find out how well you have learned the category and how you behave and so on. Now that is a typical learning experiment in psychology. And the idea, of course, is basically how quickly do people learn the category, how do they behave when they are given sort of ambiguous stimuli, for example. Okay, that is supervised learning. Now, if you try to apply that, say, to learning language, if you are learning the difference between, I don't know, the word cat and dog, okay, you see these creatures, and this has the word dog applied to it, this has the word cat applied to it, and you encounter dogs and cats which are called dogs and cats. After a bit, you begin to realize what the categories are, right? The categories are labeled, so to speak. So this is a cat, this is a dog. And then you might try out, well, is that a cat? No, that's a dog. So the things come with labels, and you try out, you ask, is this a cat? Is this a dog? And you are told, yes, that's right. No, that's wrong. And finally, after a bit, you realize what the categories are, and you then get it right all the time. That would be supervised learning. Now, unsupervised learning is basically where you are presented with a set of things, and you are told, well, categorize. Group them together. So you have a set of things, and your task is make groups out of these. Group these together into categories. You are given no assistance on how you should do it, how many categories there are. You have no idea what you are supposed to do. And the idea here is simply to find out how people do it. Learning. Okay, you have to make an assumption. You have to assume that what the linguists were doing was similar to what the child was doing. So just as the linguist went out and made a phonetic transcription and then worked out the sounds, words, and phonemes, so you would say that the child learning the language hears all this sound and then identifies the phonemes on the basis of the sound, then puts them together into words, into sentences. Basically, the task that they were the task as they saw it was, given the sound, given the input, given the narrow phonetic transcription, can you identify the phonemes on the basis of the sound and their organization and their distribution? That's basically what they were doing. They were basically pursuing a unsupervised learning, investigating whether unsupervised learning was possible. Okay? Just one point here, and the period of American linguistics in the 30s and 40s is commonly known as the Bloomfieldian linguistics. Bloomfield I mentioned, and interestingly, Bloomfield himself made this rather interesting statement. Even a perfected knowledge of acoustics, even the finest analysis of sound, will not by itself give you the phonemes of a language. We shall always have to know which of the gross acoustic features, which of the aspects of the sound, which sounds, by virtue of meanings, are the same and which are different for the speakers. In other words, if you're learning English, you come across the word coat, you come across the sound coat, and you come across the sound goat, coat and goat. You have to know that those are different words. Coat and goat are different words. They are your minimal pairs. Unless you know that, you cannot identify phonemes. You've got to know whether two sounds are, so two pronunciations are the same or different. In other words, supervised learning. And actually Bloomfield, another interesting quotation from Bloomfield, he says, the fundamental assumption of linguistics, without this assumption you cannot do linguistics, there will be no linguistics, is that in every speech community some utterances are alike in form and meaning. So in every linguistic community some utterances count as the same as other utterances, both in form, same sounds, and in meaning, they mean the same thing. Right? Interestingly, of course, because Bloomfield is well known because he tried to exclude meaning from linguistics, but at the same time he said without the notion of the same in meaning or different in meaning, you can't do anything in linguistics. Okay. Now, here. Over time. Okay. So learning experiments in psychology, I've mentioned, have overwhelmingly been in the addressed supervised learning. So psychologists have been concerned overwhelmingly with supervised learning. And these experiments are often referred to as concept formation experiments. But a critic, Jerry Fodor, has pointed out that these concept formation experiments are not in fact about forming experiments at all, about forming concepts at all, because the concepts have been formed, the experiments have formed the concepts. All you, the subject, have to do is to try to guess what they are. It's a kind of problem-solving intelligence test, actually. Now, I would like to explore the thesis that first language acquisition, at least in its early stage, can be seen as unsupervised learning. So the task faced by the language learner, that is the child, is not simply one of learning, working out the correct categorization of these labeled stimuli. The learner, first of all, you have to discover what the things are that you're supposed to be categorizing, and you also have no idea of how many categories there are. Now, take the example I mentioned before, with reference to Bloomfield. In order to work out the phonemes of English, you've got to know that coat and goat are different words. Right? Do you teach that to parents? Teach that to English children? Well, no. Foreign learners of English may well be trained on these minimal pairs, ship and sheep kind of thing. Native speakers of English, children, they are not trained. This is a ship, this is a sheep. Can you hear the difference? You don't do that with kids. You might do it with children who are thought to have a speech defect, some pathological condition. But normally, kids are not trained on minimal pairs in their language. Another interesting thing which has greatly puzzled researchers on language acquisition is that children learning their mother tongue are actually not given feedback very much. They are rarely informed that what they say is correct or incorrect. Middle-class parents might think they do it, and middle-class parents might indeed do it, but for most children of most parents in most parts of the world, they don't. In fact, in many cultures, children are simply ignored, in fact. They simply pick up the language from their siblings and other children. Okay. And the fact that children receive no or very little feedback on what is correct or incorrect has been called the problem of negative evidence, and it's a big issue in language acquisition research, as I'm sure you are aware. To give a very simple example, suppose the English-speaking child says something like, they said me no, which, as you know, is not English. Okay, the child says that. Nobody corrects the child. Says, no, you can't say that. You must say, they told me. But they said me no. The child says that. How does the child unlearn that? If nobody actually corrects and says, no, you mustn't say that, you must say this. How does the child unlearn the mistakes they make? And that is a major problem. So children are rarely given feedback. Actually, the feedback that children do get usually has to do with whether what they say is true or not. They receive feedback on the truth of what they say. They might receive feedback on the pragmatic appropriateness of what they say. No, don't be rude. Say please. Say thank you. That's what they receive feedback on. They don't normally receive feedback on grammatical or pronunciation correctness. Now, the other thing is that learning by ostension, this is when you learn the meaning of a word by pointing to it. This table, bottle, microphone, you learn words by pointing to what it refers to. That would be a kind of supervised learning, but in fact, careful study of how children learn shows that, in fact, this doesn't happen very often. Well, it might happen in, say, middle-class families, but it is not common. Many words are learned without people pointing to the thing, and for many words you can't actually point because there is nothing to point at. I mean, how can you learn the meaning of the verb to think by pointing at it? That is thinking. That is what think means, what that person, he is thinking. That's the meaning of think. Look and you'll find out what it means. It doesn't work. So learning by ostension, learning the meaning of a word by pointing to an example of it, doesn't work, cannot work for many words, and there are all sorts of problems there as well. If you learn a word, if I say microphone, how do you actually know what I'm pointing at? Is it this? Is it this? Is it black? Does microphone mean black? So there are all sorts of problems there. Come back to the question. We're now getting to the question of phonemes, the case of goat and coat. Nobody tells it will be very, very odd for someone to tell the English-speaking child that coat and goat are different words, that ship and sheep are different words. that you have a minimal pair and therefore two phonemes. Sorry, I see phonetic symbols haven't come out here, but never mind. But perhaps the child notices there are minimal pairs and thinks, coat, that's something you put on, and a goat, that's an animal. So coat and goat must be different words, k and g must be different phonemes. Well, that actually doesn't work. First of all, you would want to say that, say, sh and je would be different phonemes in English, although there are hardly any minimal pairs contrasting sh and je. Maybe I turn this round and use the whiteboard now. Okay. So, if you take the sound, the sh and je, that's what those are supposed to be. Two phonemes in English you would want to say, but there are virtually no minimal pairs. The other thing is that minimal pairs, the existence of minimal pairs, actually depends very much on how big your vocabulary is. If your vocabulary, if you only know 20 words, it's not likely that you'll have any minimal pairs amongst them. And in fact, this has been researched, a publication of 1995. They looked at I think it was the first, was it 20 or 50? Can't remember. Anyway, the first 20 or 50 words that English and Italian children knew, and it was found that there were, amongst the English children, there were no minimal pairs. The Italians, they had one, I think. But the point is that by the age of 1, children are on their way to perceiving the language phonemically, in terms of the phonemes. That is, they categorize the sounds around them in line with the phonological structure of the language they are to acquire. Now, at this stage, at the age of 1, the children don't have any words at all, or hardly, so they can't be appealing to minimal pairs. Now, how for time? Yes. Okay. Now, I mentioned supervised learning. That's what the psychologists do and have done. There's been very little stuff on unsupervised learning by psychologists. But one place where there has been some stuff on unsupervised learning, that is, you simply present a whole set of things and you let people get on with it to work out how many categories there are, how to group things together in different categories. And there has been some stuff here in our computational models, learning by computers. First of all, say a few words about so-called connectionist models. Do you know what I mean by connectionism? Can somebody shout out the Chinese term for connectionism? It's a method of computation, computer learning. Basically what happens is that you train the system on a whole set of inputs, and these are then matched with the desired outputs. So you match an input with a desired output, and then the connections between the input and the output in the machine are then adjusted so that given this input you get the right output. Then you give another input, and of course the thing gives the wrong output, but you then present it with the right output, and then the connections adjust themselves again, until after many of these presentations, typically tens of thousands, you give the input and the desired output, and the thing sort of adjusts itself to connect this input with this output. After many tens of thousands of repetitions of this, then the machine is in a state where, given a new input, it sort of gives the desired output. This has been one of the most interesting, the first significant linguistic experiments on this was done in 1986 on the learning of the past tense. So you give a input see, output saw, think, thought, walk, walked. Okay, so associating an input with an output, no rules are given the input verb, present tense, past tense, and the machine sort of works out what the regularities are, and then it is presented with new verbs it's never seen before. The question is, can it form the past tense? And interestingly, the learning curve of the machine is actually quite similar to the learning progress of children. The pattern of errors and so on is actually rather similar to the pattern of errors made by children. First of all, for example, a child would say go, went, and then you have, first of all, the child gets it right initially, and then what often happens is that the child then gets it wrong and says wented or goed, and only later does it come right again. But anyway, the point is that these connectionist models are supervised learning because the input is matched to an output. Now, unsupervised learning by machine, that has been done with various automatic pattern recognition and clustering procedures and so on and so forth. I won't go into the technical details. But a rather interesting application of this, there's been linguistic application of this. One I would mention, it comes from this thing here, a recent publication. What the chapter in this book was about, they took a phonetic transcription of English, right? A rather lengthy English text which was transcribed, phonetic transcription. They removed the word spaces, they removed the spaces between the words, and the task was, can the machine identify what the words are on the basis of what sounds occur together. Okay? Okay, basically what these systems operate with, they simply look for regularities, for patterns, for statistical properties of the input. So by doing a kind of things cluster together because they are similar on a number of dimensions. So your categories emerge on the basis of the statistical properties. Could children do this? Are children aware of the statistical properties of the input? Could children do a kind of statistical analysis of what they hear and work out that certain categories are there because things tend to occur together? Well, there was a very well-known and influential experiment done in 1996. It's something like this. Again, it's done with young infants before they have language. So they're presented with a tape record. They are presented with a recording of a set of syllables. So ba, da, ma, ba, hu, fu, lu, tu, ni, sa. Going on and on. So a random series of syllables. However, embedded within this random series, there were sets of 3 syllables which kept reoccurring. So ba, da, mu would occur regularly. And remarkably, even the 6-month-old children noticed that. They noticed that there were certain sets of syllables which were recurring. They actually noticed that this tends to be followed by that. In other words, they were identifying words, nonsense words, simply on the basis of what occurred with what. So they were noticing, I say, the statistical properties of the input. And that clearly is very, very useful when you are learning language, to be able to notice that certain things occur with other things. And a word would then be identified as a sequence of sounds which occurs in different contexts. I also want to mention the next experiment, which suggests very clearly, does this work? Can this be erased? If not, I'll have to use the chalk, okay? Back we go. What happened in this experiment? They created a sequence of sounds, say, which went something like, these are not the actual examples, but something like this. This would say ba, are two syllables which are different. And then created electronically a whole sequence of syllables which vary from here to here. So the difference between these is the same. And it's virtually impossible to hear the difference between the adjacent ones. These were not English sounds. Okay, and the subjects were told, well, we're going to play you some sounds in a foreign language. We want you simply to listen to them. Just listen to these sounds. Now, in one experiment, the frequency of these sounds was like this. In other words, this was presented least often, these were presented least often, the ones in the middle were presented most often. Okay? That's one experiment. The other group of people were presented with the same sounds, however the frequency was like that. In other words, the ones on the outside were presented most frequently, the ones in the middle were presented least frequently. Okay? Both groups heard exactly the same sounds. What was different was the frequency with which they were heard. In one group, the frequencies were distributed like that. In the other group, they were distributed like that. And the interesting thing was that after people had listened to it, the instructions were simply, just listen. Just listen to these sounds. Then afterwards, they were then presented with this one and that one, and asked the question, are they the same or different? And remarkably, the ones who had been presented with that were more likely to say they were different than those who had been presented with that. Okay? So it's as if people had noticed how often the sounds had occurred. They had noticed how often things had occurred. It's as if they were actually counting how often they had occurred. And they were constructing things like this. So if something has that frequency distribution, it looks like a single category. Okay? It looks like a single category. That's the prototype. And these are the marginal examples. Right? If something is presented with that distribution, it looks like you have two categories. You have a prototype here and a prototype here, and in the middle you have where the fuzzy boundary. As we I think talked about as I talked about in earlier lectures, red, orange, and the fuzzy boundary in the middle, which is reddish orange or orangey red. Okay, so the fuzzy. Anyway, that suggests that people were able to construct their categories, two categories or one category, simply on the basis of frequency, simply on the basis of knowing of observing how frequently things occurred. And it is a perfect example, of course, of unsupervised learning. The experimenter did not give any instructions as to what categories were to be learned, and in fact didn't instruct people at all to form categories. The instruction was simply listen. Right? So simply on the basis of listening, they were able to construct categories, and the crucial thing was the frequency with which these things occurred. Now, it is very plausible, very likely, that some of the phonetic, acoustic characteristics of phoneme categories in languages could actually be learned on the basis of this kind of frequency distribution. I'll just give one example. The difference in pronunciation between pa, and ba, pa, ba, the so-called voiceless and voiced. I don't know how much acoustic phonetics you know about, but one of the major differences between pa and ba is that with pa, you close your lips, then you open your lips, pa, and there is this so-called aspiration. There's a little period of time before you start voicing. Right? So, exaggerating, pa, And this is referred to as voice onset time, the amount of time which you can measure very precisely down to milliseconds between the opening of the lips and the beginning of activity here. So with the so-called voiceless consonants, you have this voice onset time, which is in English for per, it's about 60 milliseconds, right? 60 thousandths of a second, typically. Now, our bar, what happens is that the voicing begins more or less at the same time, perhaps with a little delay, a few milliseconds before or after, but basically it begins at the same time. So if you does this? Now, this voice onset thing is one of these distinctions that the infant, that I mentioned right at the beginning, that these 6-day-old or few weeks old infants, that's one of the things that these infants can hear. They are very sensitive to voice onset time. Right? A matter of 10, 20 milliseconds, they hear the difference, which is quite remarkable. Now, it's actually known that languages which have a voiced, voiceless, a p and a b, it uses voice onset time, but very often the actual value of the voice onset time varies a little from language to language. So some languages might be sort of 20 milliseconds more than the other. But the idea would be, it's not the idea, but this is fact, that, say, for English, so this is voice onset time, this is positive, this is negative. That is to say, this is where, for the pa, your lips open, this is when the voicing begins. It begins after you open or indeed before you open. Now the values for VOT in English are sort of distributed like that. In other words, the p value is distributed something like that and p something like that. So it's a prime case for this statistical learning. You can learn that p and b are different phonemes in English because of this statistical, the way in which the sounds are distributed in terms of how frequently they occur. So this would be, I think it's about 60. Must check. Something like about 60 milliseconds. Just under a tenth of a second is, I think, the typical value for. No, just under a tenth of a second is the typical value for the voice onset time in p, in normal speech. For b, it's somewhere around about 0 or +5 or whatever. Okay. So, given that infants are very sensitive to these small differences, and given that they are sort of distributed like this, it's very plausible that a child could acquire the two categories simply on the basis of their distribution and their frequency. Unsupervised learning, you don't need minimal pairs, you don't need instruction. But of course, once you have noticed that, then of course other things can happen, because the p-b distinction in English is not just a matter of voice onset time. There are all sorts of other dimensions to these sounds. But once the categories are sort of, okay, to use a metaphor, they are seeded, they start to grow. Once they start to grow, then you can have much more sophisticated and representations of them. Thank you. Concerning vowels, vowels, as you know or may know, the quality of a vowel is determined basically by the shape of the oral cavity, position of the tongue, position of the lips, basically by the shape of the mouth in front of the tongue and behind the tongue. And this gives rise to certain acoustic properties of the vowels, giving the formant values and so on. However, the actual acoustic property of a vowel is not the only distinguishing feature. For example, duration can be important. So, all other things being equal, the vowel in sad is longer than the vowel in said. Okay, a few milliseconds longer, but it's quite reliably longer. So sad is longer than said. Okay, if you think about it. Now, research by these two characters looked at, now, the sad, said thing, those two vowels, that is a well-known learning problem in English pronunciation. Many foreign learners of English find it very difficult to get the sad, said distinction, especially speakers of languages which have very people who speak a language with a small number of vowels. If you speak a language with only 5 vowels, now I, E, A, O, U, like, well, Japanese, Spanish, and so on. If you speak a language which doesn't have many vowels, it is incredibly difficult for these people to actually hear the difference between sad and said, or indeed the ship and sheep. So that's a well-known learning problem. So this said thing is notoriously difficult. It's notoriously difficult for foreign learners. And they found that foreign learners actually might very well rely on duration. They are not able to hear the actual difference in sound, but they actually listen for the length difference. Whereas English native speakers do not listen for length, they listen for the acoustic properties. Now, the result, of course, doesn't matter. Both the native and the non-native speakers hear the words, identify the words correctly, but they use different techniques. And their research is rather interesting. It was done, of course, using synthetic and manipulated speech. They found that second language learners of English may rely mainly on the durational differences, whereas English speakers rely predominantly on the actual acoustic things. And they found that these different strategies were found even with very highly proficient speakers of English, people who had lived in English-speaking countries for 10, 15 years. They still sort of heard the sounds differently. Right? Now, as acquisition progresses, as you get older and more experience with the language, as you get older and you have more and more experience with the language, the categories may be subject to internal organization. And here I want to make reference to, again, this is based on quite extensive and very sophisticated research, the so-called perceptual magnet effect, which is a very nice illustration of the prototype concept. Where's the cleaner? Okay. Imagine, well, you have okay, and so on. Each of those is a different sound. Each of those is a different vowel sound. And the difference between this and this is the same as the difference between this and this. So they're all the same distance from the neighbors. Okay? So it might be kind of E or A kinds of vowels, but they're all equally distant from their neighbors. Now, the idea would be that the newborn infant would perceive something like that. So that and that that and that, that and that, that and that. They're all equally different. Right? But as language acquisition progresses, as the phoneme categories begin to form, what happens is that, say, this might emerge as the prototype, as the most frequent, the best example of that particular sound. And what happens is that all the neighboring sounds, the difference between this and this is reduced. So this is perceived to be very close to that. It's drawn in. So the difference is reduced. And you might have another prototype over here, which then draws this. So the difference between that and that is less. The difference between that and that is less, perceptually. But then the difference between that and that is then increased. Okay? So you no longer notice the difference between things within the category, but you do notice the difference between things in different categories, even though objectively they're all equally distant. Okay? Now, this has been referred to as the perceptual magnet effect. The prototype is like a magnet. It pulls things in. So outlying members of the category tend to be drawn in, pulled in towards the center. And the consequence is that speakers become increasingly desensitized. You are no longer aware. You don't notice differences between members of the same category. But you do notice the difference between members of different categories, and in fact, the difference increases. You perceive them as being more different. And this actually gives rise to the phenomenon, a very well-studied phenomenon, a fascinating one, called categorical perception. And categorical perception is simply the fact that for things within a category, you don't notice the differences. Right? So you do not notice the difference between things which are in the same category, but you do notice the difference between things which are in different categories, even though the actual objective difference is the same. In other words, here, you don't really notice that difference, but the difference there is very clear. Okay? So there you have a beautiful example, in fact, of prototype effects in perception. Okay? Okay, now how is time getting on? Right. I'll go through the next bit rather more quickly. This is quite heavy stuff, I'm aware. Anyway, let's go through this. Now, okay, so I've given an account of how it is plausible, for a person, for the child learning English, to learn that coat and goat are different words. That the k in coat and the g in goat are different sounds. Okay? But that is not the same as saying that the child has learned the phonemes, has learned the phoneme concept. What our hypothetical learner will have learned are allophones, or phonetic equivalence categories, namely the kind of sound that occurs at the beginning of coat. Now, the key characteristic of the phoneme is equivalence across contexts. The phoneme, that is to say, is the level of representation at which coat and goat, lack and lag, anchor and anger, bicker and bigger, all differ in the same way. They are different in the same way, namely k versus g, irrespective of whether k occurs at the beginning, in the middle, or at the end of the word. So these words contain the same sounds, namely k and g, although in different positions within the word and syllable. The question then is, on what basis can we say that coat, lack, anchor, and bicker all contain the same sound? Because the sound is different, acoustically, physically. On what basis can you say that as I say, coat, lack, anchor, and bicker all contain the same sound? Because they don't, physically. Well, the standard answer to this, the traditional answer, is that the different sounds belong to the category because they are similar and because they are interchangeable. But there's a problem here. They are interchangeable. Well, what does it mean to say they are interchangeable? If you take the k in lack and put it in the word at the beginning of the word coat, well, actually nowadays you can do that. It's very easy with digital signal processing. Right? 50 years ago you had to take a tape recording and a pair of scissors. You had to cut up your magnetic tape and stick it back together again, which was a very messy process. And when the phoneticians of 1958 talked about interchangeability, I'm pretty sure they didn't mess about with cutting up bits of magnetic tape and sticking it together again. I don't think they did the experiments. But if you do these experiments, and you can do it quite easily now with digital signal processing, if you take the word, I don't know, peel, okay? If you play it backwards, what do you get? Leap. Well, do it, and you'll find you don't. If you play peel backwards, you get something like oop. Do the experiment, say a word, play it backwards, and it doesn't sound what you think it's going to sound like. In other words, the p and l, the p and l, whether they occur at the beginning or the end of a word, they are different, and you can't interchange them. And if you were to sort of cut one out and stick it at the beginning, it wouldn't work. And the perceived similarity, well, on what basis do you perceive two things to be similar? Well, that gives you an explanation. Things are perceived to be similar because they are in the same category. It is not the case that they are in the same category because they are perceived to be similar. Right? And here I want to refer to an absolutely crucial paper, a very important paper for categorization, by Murphy and Maiden of 1985. They proposed what has sometimes been called the theory of categories. The theory of categories. And basically they ask the question, why is it that some groupings of objects are informative, useful, and efficient, whereas other groups are vague, absurd, and useless? In other words, why do we have the categories that we have? What makes our categories useful? And why do we group things together the way we do? Now, they dismiss as too simple the view that things belong to a category because they are similar. And after all, if you take any set of objects, you can see some similarity. Okay? Their view was that category coherence is the result of some underlying principle or theory which explains why things should be grouped together. Such as encyclopedic knowledge, your presumptions about what causes what, and so on and so forth. To give you a very simple example of that, if you take the English verb to write, you can write with a piece of chalk on the blackboard. I can write a letter using a computer keyboard. I can write, or I can write. Those two activities are completely and utterly different. If you look at them objectively, completely different in terms of what I'm actually doing. Right? making marks on a blackboard or a piece of paper and pressing little keys on the keyboard. Completely different. But you can describe both of them as writing. You categorize them both as writing a letter, let us say. On what basis? Not on the basis of their similarity, because they are not similar. You put them together because of a theory, because you know about written language. You can create written language in various ways, with a pen, with a pencil, on a computer keyboard, with a typewriter. You categorize them, you recognize them as examples of writing because of a theory, because of your knowledge of what writing is and what language is and what written representations are. On the other hand, writing a letter on a computer keyboard and playing a piano are actually quite similar, if you think about it, in terms of what you do. You are pressing things with your fingers. But we call one writing and the other is called playing, because of what we know about what you're doing, about computers and piano keyboards. So it's the theory which makes your knowledge of these domains, which actually influences the way you categorize. Okay? So, rather than entities being categorized on the basis of their similarity, it is the theory. Theory, of course, not in the sense of a scientific theory. It's simply in the basis of everyday common sense knowledge. It's a theory which relates things that makes them seem similar. And perhaps it's the same with our phonemes. If you take the words who and heat, okay? Who and heat, do they begin with the same sound? Well, if you did a phonetic transcription, you would transcribe them both with H. Okay? There's my chalk. Okay. If you did a phonetic transcription of who and heat, you would do that with the same symbol. Yeah, it's the same phoneme, the H phoneme. But if you don't actually need, digital signal processing for this. You can do the experiment quite easily. Say the word who and try to isolate the first sound. Who. Say the word heat and try to isolate the first sound. Well, you don't have to be a brilliant phonetician to realize that those are different. Very different. But you think of them as the same. Why? Because they are the same phoneme. But why are they the same phoneme? What puts them in the phoneme category? Okay? My idea then is that phoneme categories emerge on the basis of your theories, speakers' theories, not your expert scientific theories, but everybody who speaks the language knows something about the language. And this information that people have about the language can influence the way in which they categorize it. First of all, you know how learning the phonology of a language is not just a question of learning what things sound like. You are normally also a speaker. So you learn also how things are made, how sounds are made. And knowledge of how sounds are made can also influence what you regard as similar. Right? So, peel and leap, knowledge of how you make the perk sound at the beginning and the end, or the L sound at the beginning and the end. Knowledge of the similar articulations could actually encourage you to think that it is basically the same sound, the same category. Also the fact that every speaker is familiar with dialectal and with register variation. As has often been pointed out, there is no such thing as the perfectly homogeneous speech community that Chomsky talked about. We all know that people speak differently, and that we, as an individual, speaks differently. So, for example, on some occasions you hear somebody say the word city, sometimes they say city. Sometimes they say computer, other people say computer. So you hear computer, you hear computer. They are different. But because you sort of know it's the same word, they're talking about the same thing, you think of that computer, the flap in computer and city as a kind of T. So exposure to different dialects and accents, different speech styles, rapid speech, slow speech, careful speech, can actually influence the way in which you form your categories. Also, of course, the knowledge of the spelling. The fact that city is spelled with a T influences your categorization of it. And perhaps also the knowledge of the morphological structure. If I say, what's the matter? For matter, what's the matter? But this, you're even madder than I am. That, of course, is a d, mad, madder. You are madder than I am. So the knowledge of the internal structure, and so on and so forth. Now, one question I want to ask, which is a rather interesting one. So how much time do we have? Okay. Are phonemes needed? I'm not talking about linguists, but do native speakers of a language need phonemes? Do they need to have their phoneme categories? And the very important quotation from Peter Yuthik, he basically says that actually you don't need phonemes. All you need to know is how words are pronounced. If you know how words are pronounced, you don't actually need to have phonemes. But phonemes are useful when it comes to pronouncing. For example, from the standpoint of word recognition, there is no need to be able to detect the similarity in the initial portions of the word big, beat, bop, burr, and bun. Nor is there any particular need for the speech perception system to extract any similarity between the way that the word park begins and the way that tip ends. However, in order to produce and reproduce any of these items correctly on another occasion, it may be helpful to note similarities in the articulation that are required to produce these. Interesting topic here also is the question of illiteracy, actually. Especially illiteracy in an alphabetic writing system like English. Now, there are one reason why a person could be illiterate is because they don't go to school. Okay? So if you don't go to school, well, that's why you are illiterate. But one of the but in sort of English-speaking countries, and I don't know to what extent this applies also to other countries which have an alphabetic writing system, but even with full-time compulsory education, it's found that there's a small minority of children who actually just don't learn to read. They just don't get it. They end up as illiterate even though they go to school. And one reason for this perhaps is that in order to master an alphabetic writing system, like English, it's necessary to recognize that cat, tack, and act contain the same sounds arranged in a different sequence. Right? Unless you realize that, you can't get hold of the alphabetic writing system. You could get hold of the Chinese writing system. You simply learn there are 3 characters, and you just learn them. But to be able to use an alphabetic writing system, you've got to do phonemic analysis. And it would seem that a small percentage of English, of children in alphabetic countries, actually don't get this. They just don't get the alphabet. They don't get the phoneme principle. And no, they have lifelong problems with reading and writing. But does this mean that they can't listen and speak? As far as I'm aware, there is no evidence that they do have problems. So, not being aware of the phoneme as a structural unit clearly makes it difficult to learn to use the alphabetic writing system, but it probably does not have an effect on speaking and listening. So one conclusion might be that the phoneme concept is not actually necessary for speaking and listening. Okay, now I'm running out of time, but I want, it's 15 or so minutes. I want to go on to perhaps more general topics here. I've been speaking about phonemes. I mentioned that American linguistics and European linguistics to some extent in the 30s and 40s was obsessed with the phoneme, right? Then, as you may know, along came Chomsky in the 50s and more or less abolished the phoneme, right? And in fact, the generative phonologists, starting with Chomsky, 50, whatever, and Halle and all those people, queried the need for a phonemic level of representation at all. What they had, going back to classical Chomskyan stuff, what you had was a so-called underlying representation, a very abstract representation of the meaning of a word, a whole set of rules, which then gave you the actual pronunciation. But basically, from a morpheme to a narrow phonetic transcription. Okay? So an extreme example of that would be, for example, if you take the words, divine and divinity, which are pronounced very differently. In Chomsky's analysis, they have the same underlying representation, something like divine. So the morpheme is the same, but then you have a whole set of rules which gives you then the pronunciation divine, divinity. There is no phoneme level. It goes directly, well not directly, it goes from the morpheme, right, which has a unique representation, down to the narrow phonetic transcription, bypassing the phoneme. Right? So, so what you had was the idea that you have a battery, a whole set of ordered rules could generate the surface form of an utterance, roughly what you call a narrow transcription with all the allophones and so on, directly from a unique representation of each constituent morpheme, with no special theoretical status attaching to an intervening phonemic representation. Now the arguments for this mostly had to do with facts of assimilation. I just mentioned some of these because they're quite interesting, although my phonetic symbols haven't come out. Okay, I'll just mention the first one. The first one is Chomsky's example. In American English, or many American speakers, the word C-A-T is cat, and C-A-N-T is can't. So cat, can't. For me, it's cat and can't. I use different vowels. But for many Americans, it's cat, can't. Cat and, sorry, this is messy. Sorry, I'm making a total mess here. Cat, so cat and can't, with a nasal air vowel. Cat, can't. Okay? It's a minimal pair. Right? Therefore, on phoneme theory, a and a are different phonemes in American English. So you've got to recognize a as a phoneme of American English, which is absurd. Right? What you have is can, can't, and then nasalization and deletion of the nasal. Okay. Anyway, I won't go into these technical things, but that's one of Chomsky's standard arguments against the phoneme. Right? Now, the generative approach to phonology was actually top-down. That is to say, okay, using the metaphor, down you have all the details, up abstraction. Okay. The details, the actual details of pronunciation are derived from the abstract representation. Right? So you start off with the abstract representation, and your rules then give you the details. Now this generative phonology actually then inverted the Bloomfieldian, the earlier approach, which is actually the opposite. It was bottom up. You started with the actual details of the pronunciation, your narrow phonetic transcription, what the natives say, and then you then worked up with phoneme, morpheme, and so on. So the Chomskyan thing is top down, and the previous approach had been bottom up. Now, it seems to be rather obvious that if you're looking at acquisition, actually second as well as first language acquisition, it's bottom up. That's certainly for first language acquisition, what the input to acquisition for the child is what is actually said. In all its detail, that is the input. Then the child has to work out what the rules are and what the regularities are, and so on. So it seems that from the point of view, as a model of acquisition, the Bloomfieldians were actually doing it right. You do start from the bottom. Right? And Chomsky, in fact, was very disparaging. He wrote very insultingly and dismissively of the taxonomic phoneme. Right? Using taxonomic phoneme also in terms of insult. Right? All those Bloomfieldians and their taxonomic phonemes. So he spoke very disparagingly of the taxonomic phoneme, as if it was somehow wrong. But the phoneme concept is, by its very nature, taxonomic. A taxonomy, if you came to my earlier talks, you'll know what taxonomies are. A taxonomy is basically a classification of things. So, animal, cat, dog, poodle, terrier, right? Or furniture, or even higher. Artifact, furniture, toy, furniture, table, chair, bed, cupboard, table, kitchen table, and so on. So it's basically a classification of things with very general terms here and more detailed classification. Scientists have taxonomies of plants and animals, right, where you classify things into groups and genus and species and so on and so forth. But the phoneme, as I say, is essentially a taxonomic, basically has its place in a taxonomy. So taxonomy have your levels. At the top you have your very general things like, say, segment. Then kinds of segments, consonant and vowel. Kinds of consonants, say obstruents and sonorants, for example. Obstruents, kinds of obstruents, t, the phoneme t would be, the T phoneme would be an example. Kinds of T phoneme, then all the allophones at the bottom. So essentially, phonemes have their place in a taxonomy. Okay? Below that level you have the allophones. Above that level you have the more abstract categories like, vowel, consonant, obstruent, nasal, and so on and so forth. Now, if you accept this, and it seems very obvious to me, if you accept the taxonomic view of the phoneme, then all that stuff, all that research and categorization that the psychologists and the cognitive linguists and all the rest of them have been doing, all that stuff on categories and taxonomies and so on that has been done in other parts of linguistics and psychology can actually be applied to phonology if you accept that segments have a taxonomy. Everything that you know about taxonomies can then be applied to this. For example, it becomes legitimate to inquire whether phoneme categories have prototype effects, and whether phonemes might be considered basic level terms, whether there's a basic level in the hierarchy, in the taxonomy. and so on. Just to recapitulate the basic level from an earlier lecture, within the taxonomy, such as furniture, chair, kitchen chair, the basic level is the level at which you normally talk about things. So, what is this? It's a table. You wouldn't say it's a piece of furniture, although it is. So, the basic level is the level at which you normally talk about things. So, furniture, chair, kitchen chair, chair is the basic level term. Now, basic level terms have properties. The properties they have, first of all, it's the level at which you normally talk about things. Secondly, it's the highest level in a taxonomy at which you can form a mental image of something. That is, if I ask you, picture or imagine what a table looks like, you can do it. But if I say, imagine what a piece of furniture looks like, you can't do it. Right? You've got to know what piece of chair, table, bed, or whatever. So the basic level is usually the highest level in a taxonomy at which you can form a mental image, you can picture something in your mind. And that basic level objects tends to be understood in terms of their parts and their arrangements and the bodily actions you perform with respect to them. If you take chair, okay, you can form a mental image of what a chair looks like. You know what parts a chair has, seat, legs, back, and how they are arranged. And you also know what you are supposed to do with it. Namely, you sit on it. And you also know what it feels like to sit on it, you know. So these are characteristics of the basic level. And basic levels have this special status because they take the second point, they maximize the number of features shared within the category. That is to say, all tables have sort of similarities which makes them different from tables. All tables have things in common which make them different from chairs and beds. Okay? So the features, the characteristics within the category sort of cluster together, but emphasize the difference from neighboring categories. Okay? Whereas if you go below the basic level, the difference between, you know, a kitchen chair and an armchair, well, they are different, but they're not so different. They don't contrast in the way in which table and bed contrast. If you go higher to furniture, it's very difficult to actually name any features at all. It's so general. Okay. Okay, the basic level is not static. Okay, we did this earlier, but let's go back to our phonemes. As I say, phonemes can be arranged in taxonomies: consonant, obstruent, bilabial, voiceless bilabial stop, and aspirated voiceless bilabial stop. This is the phoneme, that's the allophone. If you apply these criteria of the basic level, I think you have to come to the conclusion that the phoneme is the basic level category in phonology. Right? So if you apply some of these characteristics from the basic level in, you know, for furniture and all the rest of it, to phonology, actually it applies quite well. Basic level terms like chair, table, bed, these are the words you use when talking about these things. It's as if you actually think of things in terms at the basic level. You don't think of that as furniture, you think of it as a table. Now the phoneme, it would seem, although this has to be modified, but it seems to be more psychologically more salient than superordinate terms and subordinate terms. For example, native speakers of a language are usually not aware of allophonic variation in the language. English speakers have to do phonetics, they have to do linguistics before they realize that pit, spit contain different p sounds. Right? For the intuition of the English native speaker, pit and spit both contain the identical p sound. You have to do phonetics to realize that it's not true. So native speakers are not generally aware of variation. When you come to things higher than the phoneme, such as the category obstruent, actually it's very difficult to teach categories like obstruent. It's not obvious. Right? Obstruent includes stops and fricatives. Right? It's not an obvious category. It is actually important in phonology, but speakers are not aware of it. They've got to learn it, and it's actually quite difficult. Secondly, the superordinate, things like obstruent, are not very informative. If I tell you that how to pronounce a word, well, this word begins with an obstruent. Doesn't tell you very much about the pronunciation. Never say it begins with a bilabial, voiceless stop, okay, p. Then that is quite informative. You know it begins with a p, which is informative. Thirdly, superordinates like obstruent or even consonant are not associated with any images. You cannot imagine, you cannot feel what it's like to make an obstruent sound. You can't imagine what it sounds like. So you cannot imagine what a piece of furniture looks like. It's too abstract. You can imagine what a p sounds like. Right? You can form a mental image of what it sounds like. You can form a mental image of what you do to make it. Right? And here then there's a very clear analogy with the basic level term in elsewhere. You can form a mental image of a table. You can form a mental image of a p sound, but you can't form a mental image of higher categories. And phonemes are the locus of contrast, almost by definition. That's how you define minimal pairs. Just as table and chair, bed and cupboard are different contrast. And the subordinates, like kitchen chair and lounge chair, or whatever, they are different, but they are not really contrastive. And likewise, your allophones are not highly contrastive. That is almost the definition of allophones. And okay, very quickly to finish with, I mentioned earlier that, okay, I won't distract you with that. I mentioned earlier that the actual phoneme concept is controversial. There are problems, there are indeed problems with the phoneme concept, like cat and can't. Even for very well-studied languages like English, there are still difficult bits of English phonology where people can actually disagree on the proper phonemic analysis. I suspect that these problems with phonemic analysis, just to give a very, very simple example, which one should I take? The happy vowel. That is the vowel. There's now actually a tradition in English phonology to refer to different vowels not as the E vowel or the A vowel, because we all pronounce them differently. We refer to vowels by words which contain them. Okay? So the happy vowel, that is the vowel that occurs at the end, the short I sound. Right? So the fleece vowel is the E one. The fleece vowel is the E. The dress vowel is the R. Okay. So this is a standard way of referring to sounds. It avoids confusion. The happy vowel is the one that occurs at the end of happy, city, and so on, a short E vowel. And that is actually quite problematic. Is it a member of the fleece vowel, or is it of the kit, the I vowel? You could analyze it both ways, actually. But it's not obvious. So once you get into the actual details of phonemic analysis. There are these difficult little things. Right? And one thing that I suspect, I haven't actually looked at this in all that much detail, it's something in preparation, that all these problems with phonemic analysis, the kinds of things that Chomsky raised, the problems that Chomsky had with the phoneme, which are, reasonable, all these sorts of problems may be resolvable. You may be able to address these by looking at the phoneme as the basic level and by also looking at the issues that arise from the basic level. For example, the basic level is not static, as we discussed earlier. How much time do you have? Okay, to repeat the example that I gave earlier, for clothing terms. Okay, clothing is a superordinate term. Basic level clothing terms would be pullover, shirt, trousers, okay, jacket, coat. These are basic level clothing terms. What about jeans? Well, jeans would be a kind of trousers, but that is the word that you would use to describe the thing. So in a way, jeans is a basic level term because that's what you call them. Trousers is a basic level term, but jeans is a kind of trousers. So in this particular case, because jeans as a kind of trousers have become so important as a special category in itself, that's the word you use. So it's as if, the term which is lower in the taxonomy acquires a basic level status. So the basic level is not a fixed, right? There are also complications. And perhaps, to come back to happy vowel, what's happened there perhaps is that possibly it is an allophone of something, but it's acquired a special status because it occurs in a certain place, certain properties. And so perhaps there's a kind of this sort of deviation from the basic level. So it's my guess or hypothesis, supposition, that the various problems that are associated with phonemic analysis might be resolved by realizing that the basic level in phonological segments displays the same kind of characteristics as the basic level in other domains. And in fact, and the final comment, the fact that there are problems in phonemic analysis, these are problems only on the assumption that the basic level is stable and well-defined in the taxonomy. Okay, well that, as you see, is the end. So we've come full circle, in fact, right? Well, we started with phonology. Phonology is something that people don't normally associate with cognitive linguistics because phonology is not meaningful. Phonemes don't mean anything. And people often think that cognitive linguistics is all to do with meaning and metaphor and things. Phonemes don't have meaning and there's no metaphor, but they are cognitive. They are here. And in fact, by looking at phonemes from a cognitive linguistic perspective, in fact, we end up where we began, namely by studying prototypes and basic levels. Okay, well, I've gone on. I've tested your patience and attention to the very end. Thank you very much.